Hello, grade 10s. In today's lesson, we are going to complete vectors and scalars. Today, we're going to learn about the algebraic methods of vector addition. And by that, we mean we are going to add vectors mathematically. So let's first look at the addition and subtraction of vectors that are in one dimension. So that means that the vectors are parallel to one another. You and a friend are trying to move a heavy box. You stand behind it and push forward with this force, F1, of 5 newtons. Your friend stands in front and pulls the box with this force over here, F2, of 3 newtons. Calculate the resultant force. Now, in this case, we have two forces that are acting in the same direction, to the right. And when we add vectors algebraically, meaning that we use mathematical methods, we have to start off by stating a positive direction. We generally choose the direction of the motion to be the positive direction, but we don't have to. So let's look at this example where we say, let the positive direction be to the right, which is the direction of the motion. So the resultant force can be calculated by adding up force 1 and force 2. Both of those forces are positive, and 5 plus 3 is 8 newtons. Now, the fact that the answer was positive means that the force is in the positive direction, which we have defined as to the right. So again, the positive answer is indicative of the direction. Alternatively, let the positive direction be to the left. So in this case, both of these forces are acting in the negative direction. Fr equals F1 plus F2, but in this case, both forces are negative, minus 5, minus 3. So the answer to that is minus 8. And again, this negative indicates the direction. So the answer is 8 newtons. And because we said that the positive direction is to the left, and we got a negative answer, then that means it's to the right. So just note that regardless of which direction you have chosen as the positive direction, you will always derive the same answer. Let's look at another example. And in this case, the two forces are acting in opposite directions. You're trying to move a heavy box. You pull the box to the left with a force of 20 newtons. The box exerts a frictional force in the opposite direction of 15 newtons. Calculate the resultant force. Let's start off by choosing left as the positive direction. Fr equals F1 plus F2. So that's going to be positive 20 minus 15, which gives us an answer that is positive of 5, which means that it's 5 newtons in the positive direction, and positive means to the left. So it's 5 newtons to the left. If, on the other hand, we choose the right to be the positive direction, we'll still derive the same answer. Fr equals F1 plus F2. In this case, the 20 newtons is going to be the negative number, and the 15 newtons is going to be positive. Minus 20 plus 15 is equal to negative 5, which means 5 newtons in the negative direction, and a negative direction means to the left. Now that we understand how to do vector addition mathematically in one dimension, let's look at the algebraic technique for vectors that are at right angles to one another. And being at right angles is an example of two dimensions. So if we have two vectors that act at right angles, we may solve the length of the resultant, which is called the hypotenuse, using Pythagoras' theorem. So let's take a look at an example. Shayna walks to school first by traveling 15 meters north. This X over here represents displacement, which is measured in meters. Remember that displacement is the distance traveled from point A to point B in a straight line. And then 15 meters east, which is represented by x2, which is the second displacement vector. What is her resultant displacement? So here are the two vectors, 15 meters north and 15 meters east. And we now want to draw a sketch, which means that it's a vector diagram not to scale, to help us see the vector directions and to see the resultant vector, especially in terms of direction. So using the head to tail method, here's the 15 meter north vector, the 15 meter east vector, and the resultant displacement is from the tail of the first to the head of the last. Now we can calculate this resultant displacement using Pythagoras. So the resultant displacement squared is equal to displacement 1 squared plus displacement 2 squared. When you show this formula based on the Pythagoras theorem, you must use the vector symbols that are relevant to that question. So that means that Rx squared is equal to 15 squared plus 15 squared, which eventually gives us an answer of 21.21 meters. So that is the magnitude of Shayna's displacement. But remember that magnitude only provides us with half the answer. For vectors, we also need to state direction in order to have a full answer. And in order to calculate direction mathematically, we're going to use some trigonometry. So if this is a right angle triangle, this long line over here is called the hypotenuse. The line opposite the hypotenuse is called the opposite, and the line that is adjacent to the hypotenuse is called the adjacent. Now, we are generally going to use tan theta. We are going to place our theta, our angle of interest, at the tail of the resultant. So in this case, assume that the arrowhead is here at the top of the hypotenuse, and this angle is the theta. So we're going to calculate this angle as tan theta equals opposite over adjacent. So the value of this divided by the value of this will give you the tan of this angle theta over here. Now, yes, we can use sine theta or we can use cos theta, but that involves using the value of the hypotenuse. And the worry is always, well, what if we got the calculation of the hypotenuse wrong, whereas the opposite and the adjacent were values that were given to us. But technically, you can use sine theta or cos theta, but generally speaking, we go for tan theta. So let's now go back to our example and remember that we always measure the angle theta from the tail of the resultant. So here's my sketch of my vector diagram. Here is my resultant displacement. I've worked out the magnitude. Now I need to work out the direction. So using the fact that this is a right angle triangle, I can say that the tan of this angle theta over here is equal to opposite over adjacent. And that is 15 divided by 15, which means that tan theta is equal to 1. So theta is equal to 45 degrees. Now, if you're not sure how to work this out using your scientific calculator, what you need to do is take your scientific calculator, find the shift button, press on the shift button, then on the tan button, And then it gives you an open bracket. You plug in this number, you close the bracket, and you press the equal sign. And that will allow you to work out the tan of the theta of the number 1. Now, even if you predicted that this is a 45-degree angle, because this is a right angle triangle, and both of these lines are the same length, you've still got to show the calculation. Now, remember that for direction, we use the bearing method, which means from north, going clockwise until we hit our vector. So in this case, the bearing is 45 degrees. So that means that Shayna's displacement is 21.21 meters at a bearing of 0.45 degrees, because remember that using the bearing method, you always have to display 3 digits. Now, let's try some examples. Some of these we did when we did the graphical methods of vector addition. So we did them graphically, and now we're going to work them out algebraically. So a squash ball is dropped to the floor with an initial velocity of 2.5 meters per second. It rebounds with a velocity of 1.2 meters per second. Determine the resultant velocity of the ball. Now remember, step number 1 is to state a positive direction. So I have chosen down to be the positive direction. I usually pick the bigger number to be the positive direction. Now, in this case, we would say VR equals V1 plus V2 because the vectors that we're dealing with are velocity vectors. That's important. If you're dealing with acceleration, you represent it with an A. If it's displacement, it's an X. If it's velocity, it's a V. If it's force, it will be with an F. So in this case, the 2.5 is positive minus 1.2, which gives us a positive answer of 1.3 meters per second. And the fact that the answer is positive means that the resultant velocity is in the positive direction, which we have decided is down. So the final answer is 1.3 meters per second down. A man applies a force of 5 newtons on a crate. Another man applies a force of 7 newtons on the crate in the same direction. The crate exerts a frictional force of 2 newtons. Determine the resultant force on the crate. Now, in this case, you don't know the direction because you weren't told the direction that the men apply the force in, and therefore you don't know the opposing direction of the frictional force. So it makes sense to just say, let the direction of the force applied by the men be the positive direction. Alternatively, you can say, let the direction of the frictional force be the positive direction. So in this case, the 5 newtons and the 7 newtons are going to be positive values, and the 2 newton is going to be negative. So Fr equals F1 plus F2 plus F3 because I'm dealing with 3 forces here. So it is 7 plus 5 minus 2, which gives us a positive answer of 10. And what we stated is that the positive direction is the direction of the force applied by the men. So it's 10 newtons in the direction of the force applied by the men. A frog is trying to cross a river. It swims 3 meters per second in a northerly direction towards the opposite bank. The water is flowing in a westerly direction at 5 meters per second. Find the frog's resultant velocity. Now, we did this earlier in the graphical methods, and it's very interesting to compare the slight difference in the answers. The graphical method is never going to be as accurate as this mathematical or algebraic method. In this case, we're not drawing a vector diagram to scale. We just need to draw a sketch indicating the north and the west using the head to tail method so that we can get the correct direction of the resultant vector. If we point the arrow of the resultant vector here in the wrong direction, the magnitude will still be correct, but the final direction will be wrong. So this sketch is mostly important for us to identify theta, and from there we can use the bearing method. So here we're going to use Pythagoras' theorem. VR squared equals V1 squared plus V2 squared, which is 5 squared plus 3 squared, and we end up with an answer of 5.83 meters per second. So this over here, the hypotenuse represents the resultant velocity, which is 5.83 meters per second. That is just the magnitude. We also now need to worry about the direction. So to identify the direction, we absolutely need this sketch, and the angle is placed at the tail of the resultant vector. And we're going to use tan theta equals opposite over adjacent. So tan theta is equal to 5 divided by 3. So tan theta is 1.67. On your calculator, you may now plug in shift tan. It then shows you a tan to the minus 1 with an open bracket. You plug in 1.67 and you close the bracket. And you press the equal sign and you will get a value of 59 degrees. Now the 59 degrees is this angle over here. Remember, the bearing method is from the north going clockwise until you've hit the vector. So if we take a look at this, well, we make a little compass at the tail of the resultant. Here's the north line. And then we go clockwise all the way until we hit the vector. So essentially, if we go all the way from north, all the way around, back to the north, that's 360 degrees. So we can say 360 minus 59, and that will give us the angle from the north going clockwise until we hit this vector. So the bearing is 360 minus 59, which is 301 degrees. So the frog's resultant velocity is 5.83 meters per second at a bearing of 301 degrees. Now remember that when it comes to algebraic mathematical methods of vector addition, when it's in 2 dimensions, you will only be asked for questions where the vectors are acting at right angles to one another. So here's another example. A plane is traveling with a velocity of 100 kilometers per hour south. So here is the 100 kilometers per hour vector. It encounters a side wind to the west, which is in this direction over here, of 25 kilometers per hour. So here's a sketch, not drawn to scale, of my head to tail method. Determine the resultant velocity of the plane. So in my sketch, the resultant velocity is from the tail of the first vector to the head of the last vector. The length of this line represents the magnitude of my velocity, and I can work out the direction based on the theta, which I place at the tail of the resultant. So the resultant velocity squared equals V1 squared plus V2 squared, which is 100 squared plus 25 squared, which eventually gives us an answer of 103.08 kilometers per hour. That is the magnitude of the resultant vector. To identify the direction, the sketch becomes key. The angle, again, is placed at the tail of the resultant. Tan theta equals opposite over adjacent. So it is 25 over 100. So tan theta is 0.25, which means that this theta angle here is 14.04 degrees. Remember, we're using the bearing method. So we make a little compass at the tail of this resultant, and we go from the north all the way until we hit our vector. So here's the north. From here to here is 180 degrees. 180 plus 14.04 degrees will indicate the direction, will indicate the resultant direction of this vector. So the bearing is 180 plus 14.04 degrees, which is 194.04 degrees. So the plane's resultant velocity is 103.08 kilometers per hour at a bearing of 194.04 degrees.